Good morning, my dear students. My name is Nir Toyana. I am available at the Hamlet Tuition Center, Brahmatul, Kathmandu, and the Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and today we are going to start our new lesson light. Okay, this is your lesson number 7. Okay, lesson number 7, light. Well, I don't think I need to introduce you light once again, do I? Well, you have studied this in grade 6 and 7 as well. Light is a form of energy, isn't it? Light is a form of energy. Well, there are two kinds of things in the universe: energy and matter. Energy and matter. Matter has some mass, energy does not have any mass. Matter, you can take weight, or matter occupies space, but energy, you cannot take weight of energy, or energy does not occupy any state, any space. Okay, so light, is it matter or energy? Well, light is energy. And what kind of energy is it? It gives us sensation of vision. So light is the form of energy that gives us sensation of vision. Now it is because of light energy that we are able to see different things. Okay, can you see anything inside a dark room? Definitely no, you cannot see anything inside a dark room because there is no light in the dark room. Yes, or can you see if someone is blocking their face? Then also no, you cannot see their face because the light have been blocked and the light cannot pass through that blocked object. Okay, that's why you need light energy to see things. It is only because of light energy that you are able to see things. Okay, now light is actually the energy possessed by fast moving photon particles. Now what is photon particles? Photon particles, well, in higher studies, higher level, you will study that everything in the universe are made up of elements. Yes, everything in the universe are made up of elements, and elements are made up of atoms. Okay, and atoms are made up of three basic or fundamental particles: proton, neutron and electron. Okay, three fundamental particles: proton, neutron and electron. That is what you will study in school level, but in reality there are more fundamental particles. However, these three particles are the most common particles which occurs in highest number. These three particles: proton, electron and neutron. That's why they are also known as subatomic particle, whereas there are other fundamental particles in the universe. Okay, among them photon is also one of them. Okay, so when photon particles move very fast, then they possess the energy light. Everything does not have light. Okay, everything does not have light. Yes, now the photon, only the photon particles which is moving at very high speed, that has light. Yes, now photons are usually released by very hot object. Every object has photon particle, but they release it only at very high temperature. An example, for example, the filament of a bulb. Okay, when filament of a bulb is heated, it produces light. Well, the filament lamp you might not have seen in recent days because nowadays they are not very much in use. Okay, nowadays we use either CFL or LED or fluorescent lamp, that means tube light. Okay, but filament lamps are simply out of fashion, and that's why you may not have seen it. Anyway, you can take another example like lighting a candle. Yes, when the candle becomes very hot, only then it produces light. Yes, does candle remain cold when it gives off light? No, it burns, isn't it? when the fire is burned in the wick of candle, okay, then only it releases light energy. Okay, so light energy is, or photons are released by very hot object. That means light energy is produced by very hot object. Now this is another important information. Speed of light in air is 3 × 10⁸ meter per second, and this is because photon particles move at this speed in air. Photon particles move at the speed of 3 × 10⁸ meter per second in air. Okay, that's why speed of light is this much. Now there are two basic terms regarding the light: ray and beam. Okay, now as I said that light is actually fast moving photon particles. Yes, light is actually fast moving photon particles. Then if I consider a single photon particle, then I can trace the path of this photon particle as well. Can I or not? Are you getting me or not? If I consider a single photon particle, then I can actually trace the path of this photon particle. Yes, so that traced path of this single photon particle or very small number of photon particle would be a narrow beam, a narrow path. Yes, in this example you can say in this diagram, okay, this diagram actually shows, okay, in terms of photon it is also beam, okay, however to our eyes it is a ray. A single ray of light is this much thin, even thinner than this. Okay, so you can say ray is a very thin path of light. In general you can say ray is a very thin path of light. Okay, but actually speaking, ray is the path traced by single photon particle. Okay, the path traced by movement of single photon particle is called a ray, and in general ray is the narrow path of light, and it is represented by single straight line, okay, with arrow. Single straight line with arrow. Okay, ray of light is indicated by single straight line with arrow. Yes, however, no source of light release single photon particle. Do they? No, definitely no. No source of light release single photon particle. Yes, most of them release bulky photons. Bulky photons means millions of photon particles at the same time. That's why in nature, in natural setting, you can never get a ray of light. You can never get a ray of light in natural setting. What you get? You get beam of light. You get beam of light. Beam is the bulky path of light. Bulky means in mass. Like in this diagram you can see large number of light rays are coming into the room from the window. Now collection of all those millions or billions of light rays is known as beam. Okay, so it is represented by multiple straight lines with arrows. See, this is how beam of light is represented. This is how ray of light is represented, and this is how beam of light is represented. Understood the concept of ray and beam? Okay, you must also understand the concept of photon. Don't forget this word, photon. Okay, now let's go to next page. We have just discussed what is beam of light. Yes, beam of light is a collection of rays of light. Now there are three types of beam of light. If it is the collection of rays of light, then the light rays might be parallel to each other. Yes, the light rays might be parallel to each other. If they are parallel to each other, then this kind of beam is known as parallel beam of light. Okay, in another instant, the light rays might be coming from different source. Okay, they are coming from different angle, and then they all meet at a single point. or you can say all of these light rays are coming toward single point, then this kind of light ray is known as convergent beam. Converge means to meet. Converge means to meet, and its opposite is divergent. Diverge means to move away. Okay, so if the light rays are moving away in different direction from single point, if the light rays are moving away in different direction from a single point, then this kind of light ray is known as divergent beam of light. Okay, the parallel beam of light, a beam of light in which rays are parallel to each other and never meet each other, is called parallel beam. If they are moving perfectly parallel to each other, then they will never meet at all. Okay, and this kind of beam is found in light rays coming from distant source. If the light rays are coming from sources which is very far, then the light rays are parallel to each other. Okay, actually the parallel beam of light is a small part of divergent beam. Okay, it is a small, very small part of divergent beam. So parallel beam of light is theoretical. Okay, it exists only in reference to human perception. In nature and universe, there is no parallel beam of light. Okay, parallel beam of light is just like a big boulder for an ant. Yes, the ground on which the ant is standing is actually flat to the ant, isn't it? But to us, the boulder is round. Okay, well, the second one is convergent beam. We have already defined it. A beam of light in which all the rays meet at a point is called convergent beam, and it is found in beam of light emerging from convex lens or reflected by concave mirror. Well, we still have to study about this lens. Okay, we still have to study about convex lens and concave lens, convex mirror and concave mirror. We haven't studied anything about those spherical lenses and mirrors, but that is the main part of our lesson. Okay, in grade 8 you will study about mirror, and in grade 10 you will study about lens. So let it be for now. We will discuss it in detail. Okay, but in convergent beam of light ray, always remember that what sources produce it? It is produced by convex lens and concave mirror. Okay, convex lens and concave mirror. Okay, the third one is divergent beam of light, a beam of light in which all the rays appear to move away from a point is called divergent beam. See here, all the light rays are moving in all directions, in different directions from the same point. Yes, this is divergent beam. And most of the source of light emit light rays in all directions. If you lit an electric bulb, or if you lit a candle, then will the light go in only one direction? No, definitely no. Light goes in all direction in spherical motion. Yes, up, down, left, right, whichever direction you say, light goes in all direction. Okay, that means if you take it as a whole, the light rays coming out from the candle would be divergent beam. Okay, similarly the light rays coming from tube light, the light rays coming from sun, from fire, whatever source you say, they all emit light ray in all direction. Okay, well, so the light rays of so the rays of light in general are divergent, and I already told you parallel beam of light is also a very small part of divergent beam. Okay, it is also found in the beam of light emerging from concave lens or reflected by convex mirror. See, here you might get confused. these two are just opposite. Yes, here you have convex lens, here you have concave lens. Here concave mirror, here convex mirror. Okay, be careful on that part. Okay, if you do not have any confusion in types of beam of light, then we will go to next topic, reflection of light. Okay, we will discuss only this much. Okay, reflection of light. You know what is reflection? Reflect means to come back, bouncing back. What happens if you throw a ball to the wall? What happens? Will it stick to the wall? No. Will it go through the wall? No. Will it simply drop off the wall? No. What happens? It will bounce back. Yes, it will bounce back to you, and that phenomenon is known as reflection. Reflection means bounce back. Okay, to bounce back after striking a surface is known as reflection. Now, just like the ball, light also exhibit the same phenomenon. Okay, because we already told you that, we have already discussed that light is actually the energy possessed by fast moving photons. Okay, since photons are also particles, they also bounce back whenever they hit a surface. Yes, okay, so when light rays strike on a surface, the light rays bounce back to the same medium, and this phenomenon is called reflection of light. Any confusion? In diagram, you can see it in diagram. This is the light ray coming from source. Yes, this is a light ray coming from source, and this is a surface which do not absorb light ray. Okay, so when light ray strike on a point on this surface, what is happening? The light ray is moving in the same medium. It is moving back. So this light ray is called reflected ray. Yes, this light ray which is coming from the source is known as incident ray. Okay, and the light ray which is being reflected is known as reflected ray. The light ray which is formed after reflection is known as reflected ray. Okay, now the point on the surface where incident ray strikes is known as point of incidence. जहाँ से incident ray आइपुग्छ त्यो चाहिँ के हो त point of incidence. Okay, and at the point of incidence you can always draw imaginary perpendicular line. Okay, you can always draw imaginary perpendicular line at the point of incidence, and this perpendicular line is known as normal. Okay, it is normal. Got it? Okay, now you can see that incident ray is actually making an angle. Incident ray is making an angle to normal. Yes, this is the angle made by incident ray to the normal. That's why this angle is known as angle of incidence, and it is indicated by I. It is indicated by I. Similarly, the reflected ray also makes an angle with normal. Yes, and this angle is known as angle of reflection. Okay, now see the definitions here. The light rays coming from the source are called incident rays. The point on the surface at which incident rays strike is called point of incidence. The light rays which are bounced back from the surface are called reflected rays, and the imaginary line drawn perpendicular to the surface at the point of incidence is called normal. Yes, the angle made by incident ray to the normal is called angle of incidence, and the angle made by reflected ray to the normal is called angle of reflection. Okay, you understand this much term? Okay, if you do understand, then let's go to the laws of reflection. Okay, laws of reflection states us as this incident ray, normal and reflected ray, they all lie in same plane. Same plane means if you keep a paper, so as to trace incident ray, then normal and reflected ray can also be traced on the same paper. Got it? If you keep a paper so as to trace the incident ray, then the normal and reflected ray can also be traced on the same paper. Understood? Okay, that was the first point or first law of reflection. The incident ray, normal to the point of incidence, and reflected ray all lie in the same place. I told you 3 lines. Yes, incident ray, normal. Now I already told you that you can draw millions of normals over the surface, but which normal are we talking about? The normal that we drew to the point of incidence. Yes, so normal to the point of incidence and reflected ray. Okay, they all lie in same plane. That is the first law. And the second law says that angle of incidence is always equal to angle of reflection. Well, the angle formed by incident ray to normal, this angle is always equal to angle formed by reflected ray to normal, angle of reflection. Okay, that was the second law. Okay, now we are going to end our class for today. Okay, we will continue our lesson in our next class. Yes, and in our next class we will discuss about reflection of light by a plane mirror. Okay, how does a plane mirror forms an image? We will discuss about that in our next class. Okay, until then, thank you class.